Hello, good day. I hope you are fine. Today we are going to find an answer to a few interesting questions about options. How much is the value of an option? What is its fair price supposed to be? How can we calculate the value of an option? This video focuses on binomial option pricing model, which is an important and useful tool for option valuation. There are two types of models covered in this video, the one-step and two-step binomial models. We will use the models to value call option, put option, as well as European and American options. Since this is an introductory course in finance, I will focus on the use of formula so that students will form a basic understanding about how the binomial option pricing model works. At the end of this learning session, it is hoped that students can apply the model to calculate the value of call option and put option. Stay tuned and let's learn together. The binomial option pricing model was developed in 1979 by Coase, Rose, and Rubinstein. In this slide, I list out the reference to the original article, which is entitled Option Pricing, a Simplified Approach, published in the Journal of Financial Economics. What is a binomial option pricing model? It is an option valuation method. It is a useful and popular technique for pricing a stock option. The binomial option pricing model involves the construction of a binomial tree. What is a binomial tree? A binomial tree is a graphical representation of possible values that a stock and an option may take at different loss or time periods. The binomial model assumes a discrete time, one period world, in which the security price follows a stationary binomial stochastic process, so that at the end of the period it can be higher or lower than at the start of the period. This means the underlying security prices can only either increase or decrease with time until the option expires worthless. The simplest type of option to price is the European call option on a security that makes no cash payments. For example, the underlying asset is a non-dividend paying share. We shall start by learning from the simplest form. From there, we will move on to more complicated forms such as a two-step binomial model and American option. This slide shows the key symbols and formula for the one-step binomial model. S0 refers to the stock price at time 0. U means upside change, and D stands for downside change. SU is the share price with upside change. SD is the share price with downside change. F stands for the value of option. P stands for risk-neutral probability. I will explain further about risk-neutral probability in the next slide. There are two sets of formula listed for the calculation of option value F. Both formulas are highlighted in pink color. Why is that so? Do you know the difference between the two formulas for F? Well, the first formula on the bottom left of the slide is used with assumption of continuous compounding. The expected value of option in future is discounted with e power of negative RT. The second formula on the bottom right of the slide assumes discrete compounding. The expected value of the option in future is discounted with 1 plus interest rate. To sum up, the option value is the present value of future expected value of the option, considering both the probability of upside and downside change. What is a risk-neutral probability? The risk-neutral probability is represented by symbol P. The risk-neutral probability is based on three assumptions. First, investors are indifferent about risk. Second, the expected return on the stock is equal to the risk-free rate of interest, which is very minimal. Third, the market is in equilibrium. There is no opportunity for arbitrage. Why is the formula of risk-neutral probability is as such? How is the formula developed? We are going to understand further. For continuous compounding, the future value is equal to present value multiplied with exponential compounding factor e power of r and t. The expected return can be explained in two ways. First, if we assume investors will earn a risk-free rate of return, the expected return is e power of RT. Second, the expected return is also the weighted average of the probability of upside and downside change. Both the explanations of the expected return can be combined into an equation, as highlighted in yellow. When we rearrange the equation and solve for P, we shall obtain the final formula for risk-neutral probability, which is highlighted in pink. The steps for option valuation using a binomial tree can be summarized as follows. First, create the binomial price tree. From share price at time 0, S0, forecast the SU and SD based on upside and downside change. Second, compare the SU and SD with the exercise price of the option and find the intrinsic value of the option at each final node. This means find the FU and FD. Third, from FU and FD, find the option value F at earlier node by using discounting methodology. Let's look into an example. We shall value a call option. A 3-month European call option on the stock has a strike price of $21. The risk-free rate is 12%. The upside and downside change is 10%. The current stock price is $20. With upside change of 10%, the current stock price of $20 times 1.1 will give us $22. On the other hand, with downside change of 10%, the current stock price of $20 times 0.9 will give us $18. When the share price is $22, the call option is in the money. The intrinsic value is $22 minus exercise price of $21, and the intrinsic value of the call is $1. When the share price is $18, the call option is out of the money. The intrinsic value is 0. Our objective is to calculate what is the value of the call option today at time 0. The calculation of the value of the call option are summarized in this slide. First, You can make use of the risk-neutral probability formula to calculate P. P is equal to 0.6523. Therefore, 1 minus P is equal to 0.3477. Next, you can make use of the option formula to calculate F, which is the value of the call option. Next, we are going to learn how to construct a two-step binomial model for option valuation. You can make use of the formula given in the slide or use the original one-step binomial formula and repeat the process twice at the first node and second node of the binomial tree. I will show you how. In this example, the current stock price is $20. The upside and downside change is 10%. The strike price is $21. First, we construct the possible future stock prices based on upside and downside change of 10%. For example, $20 times 1.1 is equal to $22. $22 times 1.1 is equal to $24.2. At the final node, the intrinsic value of the option is calculated. For example, at stock price of 24.2, the intrinsic value of the call option is 24.2 minus 21 and is equal to 3.2. When the stock price is at 19.8 and 16.2, the call option is out of the money, and the intrinsic value of the call option is 0. This is a two-step binomial model. Each time step is 3 months long. The risk-free interest rate is 12% per annum. We can make use of the equation of risk-neutral probability to calculate P. This slide shows the detailed calculation at each node. The calculations start from the final node, that is, node D, E, and F. At the final node, we compare the stock price with the exercise price to determine the intrinsic value. Then we move backward to node B and C. We use discounting technique, as represented by the formula highlighted in pink, to find the option values at earlier nodes. The node A is the last to be calculated, which is the value of the call option. Alternatively, the value of call can be obtained using two-step formula. This is the formula to use. You can substitute the value accordingly and find the value of the call option, which is 1.28. Next, we are going to learn how to value a put option. The steps for valuing put options using a binomial model is the same as valuing call. Take note that a put option gives the holder the right to sell the underlying asset at the stated strike price within a certain time period. If the market price of the underlying asset decreases, then investor can make a profit from the put option. In this example, consider a 2-year European put option with a strike price of $52. The current stock price is $50. The stock price is expected to move up or down by 20%. The risk-free interest rate is 5%. Let's calculate the value of the put option. For your convenience, this slide shows the summary of the two-step binomial tree. The stock price changes by 20% at end of year 1 and end of year 2. At expiration at end of year 2, the put option is in the money when the market price is below the strike price of $52. The value at time 1 and time 0 is calculated using the option formula. Here I have presented the detailed calculations from the final notes, time 2, moving backward. The put option value at time 1 is calculated using the one-step formula, where the put option values are 1.4147 and 9.4636. Next, we move backward to time 0. We use the same one-step formula to calculate the option value at time 0. This slide summarizes the detailed working and calculation using a two-step formula. The answer is the same as the previous slide, in which we calculate the present value of the option one step at a time. In this slide, a two-step formula is used directly. Do you notice that the answer is the same? Next, we are going to learn how to value an American option. Take note of the key difference between European and American option. An European options can be exercised on the expiration date, while American options can be exercised anytime up to the expiration date. Therefore, the valuation of American option is slightly different. The procedure is to work back through the tree from the end to the beginning, testing at each node to see whether early exercise is optimal. The value of the option at the final nodes is the same as for the European option. The values for the option at the final nodes are also unchanged. At earlier nodes, the value of the option is the greater of the value given by the equation or the payoff from early exercise. The stock price and their probabilities are unchanged. Let's consider the same example for a 2-year put option. From the two figures, what are the key differences? Do you notice the difference? Well, the market prices of the stock and the possible changes in year 1 and year 2 are the same. The values of the option at expiration date are the same. The only difference is at node C, where the option value is $12 instead of 9.4636. Why is that so? This is because at node C, the put option is in the money and it will be exercised. At node C, the intrinsic value of the put option is the strike price of $52 minus the market price of $40, and the intrinsic value is $12. The value of the put option at time 0 is higher for American option, as we discount higher values at node B and node C to obtain the value of the put option at time 0. The American put option is worth more than the European put option. This slide shows the detailed calculation and explanation. I hope you will spend some time going through the calculation. The important point is, after we have calculated the option value using the one-step formula, we shall compare the option value with its intrinsic value. If the intrinsic value is higher, as in the case of node C, Then the put option will be exercised. The value of the option will be based on the intrinsic value. If the intrinsic value is lower, as in the case of not B and not A, we will not exercise the put option. Before we end this video, it is worth noting that the binomial models that we have just seen are unrealistically simple. In practice, the time paths of the option can be more. Therefore, the parameter U and D can be adjusted to match the stock price volatility, and the risk-neutral probability can be adjusted accordingly. Finally, we have come to the end of this video. I hope you have learned some knowledge from this video. If you like this video, please click like, share or subscribe to my YouTube channel. Thank you. See you and goodbye.